Okay, welcome back. Today for day 22. Yesterday was this was this allergen assessment thing, which was pretty easy. Yeah, let's just jump right in. Crab combat. It only takes you a few hours of sailing the ocean on a raft for boredom to sink in. Fortunately, you brought a small deck of space cards, which links to last year's day 22. So this is apparently a running thing from last year. Okay. You'd like to play a game of combat, and there's even an opponent available, a small crab that climbed aboard your raft before you left. Oh, 6 seconds for part 2. I think Moran was having like 26 milliseconds or something for part 2, or for both of them. I mean, I haven't solved it yet. Before the game starts... fortunately it doesn't take long to teach the crab the rules. Surprisingly smart crab. Before the game starts, split the cards so each player has their own deck, which is my puzzle input. Then the game consists of a series of rounds. Wait, so split the cards so each player has their own deck. So is 1.5 milliseconds. Oh wow. Wait, so is my puzzle input... Oh, my puzzle input is both. Right, okay. Then the game consists of a series of rounds. Both players draw their top card, and the player with the higher valued card wins the round. The winner keeps both cards, placing them on the bottom of their own deck, so that the winner's card is above the other card. If this causes a player to have all of the cards, they win, and the game ends. For example, consider the following decks. This arrangement means that player's 1 deck contains 5 cards with 9 on top and 1 on the bottom, so they go top to bottom. Player 2's deck also contains 5 cards with 5 on top and 10 on the bottom. The first round begins with both players drawing the top card of their decks, 9 and 5. Player 1 has the higher cards. Both cards move to the bottom of player's 1 deck, such that 9 is above 5. In total, it takes 29 rounds before a player has all of the cards. So they start out like this. Player 1 wins this round, so he gets both of these cards added to his deck. Same thing again, 2 versus 8. Player 2 wins, so he gets the 8 and the 2. So on and so forth. Until player 1 doesn't have a deck anymore, and player 2 has all of them. Once the game ends, you can calculate the winning player's score. The bottom card in the deck is worth the value of the card multiplied by 1. The second from the bottom card is worth the value of the card multiplied by 2, and so on. With 10 cards, the top card is worth the value on the card multiplied by 10. Okay. Right. Okay, yeah. So just multiply by the position of the card, sort of reversed. So once the game ends, the winning player's score is 306. Play the small crab in a game of combat using the 2 decks you just dealt. What is the winning player's score? Well, that should be easy enough. Let's save this into day 2. not day 2, day 22. Yeah. I think we're gonna be using a deck. No, is that how you write it? Yeah. Oh, it's decks with an S on the end. So basically it's a double-ended queue, so you can push and pop to both ends. Yeah, so you have stuff like add first and pop last and peak and all of that, which should be a decent structure for this. Let me open the day 22 input here. Add that S. We also do string utils and sec utils. We're probably going to be using those. So we have 2 stacks and they're split by this empty line. So we can say our dex is equal to, just read the input file. Actually, let us do what we did yesterday and just store this in data first, which makes it easier to switch between the test and the test data and the actual input set. We are gonna split this on a double new line. So the new line that is here after the 46 and the new line that's here. So that would split them into 2, both starting with players. Yeah, something like this. So it's player 1 and all of their numbers, and player 2 and all of their numbers. So then we can map split lines. That should now create a sure. That should give us both of these stacks as these long lists, and this one has an empty one, and they also have the player thing in there. So we are going to you're gonna keep entries if the length is larger than 0 and the first character is not a P. And then we're going to map parseInt over this list. So that should just give me 2 lists. Ooh. What is this complaining about? Got string character for the comparison. Oh, right. There. Well, I guess we can do this. Like that. No? Why isn't this happy? Split lines cannot be assigned to. Oh, it's because this is filter it. How does that work again? Filter it is with all that fulfilled the predicate. So that's just the same thing. I guess keep it if is in place. So yeah, we have one deck that starts with 21, ends with 46, and one that starts with 22 and ends with 28. 21, 46, 22, 28. Yep, that looks good. Oops. And let me just do that. Just so we don't go over 80 lines. I'm actually going to keep those in 2 separate blocks. But I'm going to put this into its own block. So player 1 has... Now we're going to be using the deck, so we need to convert that string to a deck, I guess. That's not great, is it? Could have added them directly into a deck. You know what? Let's do that. Init the deck event, and do the same for player 2. And here we're not gonna do filter it. Well, we are gonna do filter it, but yeah, we're gonna do. But that doesn't map it. What's the best way of doing this? I actually don't need to assign this to anything. For deck in this split, for line in this thing, if this predicate holds, then player 1 dot push parse int line. So now it just adds them all to player 1. Oh, and this should of course be line and line. This is called push first. Why is this not happy? Add last, I guess is what we want. There we go. No. What is it complaining about? At last. Oh. These needs to be variable, of course, that they can change. So var and nim makes stuff mutable, while let keeps it a sort of assign once kind of thing. Yeah, so now they're all added to the same player. We are gonna do right. We have 2 players here. We're gonna do this. It's not the prettiest in the world, but wrong number of variables, really? You're sort of supposed to be iterating over a sequence. Can I do this? I can't, right? because it's not a reference. Yeah. But what we can do is, I guess we can do this. Say that this is a deck event, and just say that this is a deck event, and this is in its deck event, and then say one equals current player. We need some kind of it annoys me that I can't get the value out of there. And this isn't, yeah, it's a normal object. I guess it has a length. Yeah, it has a length. So you can say if player 1.length is 0, then assigned to him, otherwise assigned to player 2. A bit of an ugly way of doing it, but it'll work. Oh, and of course, do I have to initialize decks? (21, 46, 22, 28). That's right. Yep. Do I have to initialize decks, or can I do this? That seemed to have worked fine. Then this can also just be a deck event. And I can remove that. There we go. Okay, so now we have our 2 players. Now we need to run this while player 1.length is larger than 0 and player 2.length is larger than 0. So basically, as long as someone has a number, then we do if player 1 dot peak first is larger than player 2 dot peak first, player 1 dot add last, player 1 dot pop first, and player 2 pop first. Otherwise, do the same thing, but with this one before that one. Let's do the test data here first. Which was here. Just to check that our result for the test set is good. There we go. Three, 2, 10, 6, 8, 5, 9. 3, 2, 10, 6, 8, 5, 9. 4, 7, 1. 4, 7, 1. Yep, that looks good. So now we need to calculate the score. And the score should, while the winner be there. And while this has to be a variable, winner.length is greater than 0. Then score is plus equal winner.poplast times just counter. Let's put these into a block. Counter is 1 and increase the counter. And echo out the score. 306, I believe that was the correct number. Yep. So basically what this does is start the score, pick the winner, which is the one that has stuff left in it, do the counter, and then just pop the last one and time it by the counter, which is how the score is counted in this game. We remove that. And now we can run this, and this should be our day 1. Hurrah! Okay, people ask me how fast this was. Oops, maybe I should tell it what to compile. You know what? Let's go real fast. Yeah, basically negligible. Part 2. I mean, there's probably a faster way of doing it. No, that was not what I wanted to open. We're not really doing this. I'm not really doing these for like speed. At least not execution speed. Anyways. Yeah, you lost to the small crab. Ah, so he was apparently... Ah, wait, we don't know the... We don't output the winners. Fortunately, crabs aren't very good at recursion. To defend your honor as a raft captain, you challenge the small crab to a game of recursive combat. Oh, there's another hidden message. For some reason, nobody wants to play recursive Twilight Imperium with me. Oh my goodness. I've played Twilight Imperium once. I played it over 2 days because it takes so long to play that game. And I just remember the feeling of like since it was my first time playing it, it was pretty obvious that I was going to lose. And I just remember that feeling of getting up in the morning and thinking to myself like, yeah, what am I going to do today on my Sunday? Oh yeah, that's right. I'm going to go and lose a board game. That's what I'm doing today. Man, that was a bad feeling. So yeah. Recursive combat still starts by splitting the card into 2 decks. You offer to play with the same starting decks as before, it's only fair. Then the game consists of a series of rounds with a few changes. Before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. Previous rounds from other games are not considered. This prevents infinite games of recursive combat, which everyone agrees is a bad idea. Wait, what? If there was a previous round in this game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. Okay. So basically, if we end up in a situation where we're sort of back to state that we've been in before, I guess. Otherwise, this round's cards must be in a new configuration. The players begin the round by each drawing the top card of their deck as normal. If both players have at least as many cards remaining in their deck as the value of the card they just drew, have at least as many cards remaining in their deck as the values they first drew, the winner of the round is determined by playing a new game of recursive combat. So if both players have at least as many cards remaining in their deck, right, okay. Otherwise, at least one player must not have enough cards left in their deck to recurse. The winner of the round is the player with a higher value card. Right. Oh, right, so a round is sort of... Right, yeah, okay. As in regular combat, the winner of the round, even if they won the round by winning a subgame, takes the 2 cards dealt at the beginning of the round and places them on the bottom of their own deck, again so that the winner's card is above the other card. Note that the winner's card might be the lower valued of the 2 cards. Right, if they won the round due to winning a subgame. If collecting cards by winning the round causes a player to have all of the cards they win and the game ends. Here is an example of a small game that would loop forever without the infinite game prevention rule. During a round of recursive combat, if both players have at least as many cards in their own decks as the number on the card they just dealt, the winner of the round is determined by recursing into a subgame of recursive combat. For example, if player 1 draws the 3 card. What? Player 1 doesn't have a 3 card. Is player 1 supposed to have a 3 card? What? For example, if player 1 draws the 3 card and player 2 draws the 7 card, this would occur if player 1 has at least 3 cards left and player 2 has at least 7 cards left, not counting the 3 and 7 cards that were drawn. Ah, right. Right. To play a subgame of recursive combat, each player creates a new deck by... Oh, this example was just to show the infinite recursion prevention thing. Right. So, and that would happen because player picks 43, this player picks 2. Otherwise, the round's cards must be in a new configuration. The player begins the round by each drawing the top card of the deck as normal. If both players have at least as many cards remaining in their deck as the value of the card, I mean player 3 doesn't, or player 1 doesn't because he doesn't have 43 cards. Otherwise, at least one player must not have enough cards left in their deck to recurse. The winner of the round is a player with a higher value card. Yeah, so player 1 wins round 1 and gets the 42 and the 2. Then player 2 wins this round, gets 29 and 19. Then this guy has 14. Player 1 now has the 43 again. Okay, I'm not going to go through that. Yeah. To play a sub-game of recursive combat, each player creates a new deck by making a copy of the next cards in their deck. The quantity of cards copied is equal to the number on the card they drew to trigger the sub-game. Right. During this subgame, the game that triggered it is on hold and completely unaffected. No cards are removed from players' decks to form the subgame. For example, if player 1 drew the 3 card, their deck in the subgame would be copies of the next 3 cards in their deck. Yeah, I thought about the whole deck. I guess Zoom isn't in the stream. Yeah, I thought about moving. He said I went with decks today, even though I think I could have done it with just a second, moving the top of the deck index. Interesting. How much faster would it be? Yeah, I thought about that as well. But well, I had already started implementing it with decks. Right. To play a subgame, yeah, okay, so we create a subgame by copying that amount of cards. During this subgame, the game that triggered it is on hold, blah blah. For example, if player 1 drew the 3 card, their deck would be copies of the next 3 cards. Here's a complete example of gameplay where game 1 is the primary game of recursive combat. So game 1. Score calculation for hashing. Score calculation? What? Is this scored differently as well? I'm just going to scroll down to below this quickly. After the game, the winning... okay, that's the same rules. Right. Yeah, so it starts out the same. Player 1 wins this round because he doesn't have 9 cards. So, I guess he doesn't have 5 cards, so they're not going to do the copy thing. Same with this, exactly the same as before. This one also exactly the same as before. Same with this. Same with this and this. But here, no, because he doesn't have 5 left. So same here, same there. 4-3. This is a subgame because he have 4 cards left. He have 3 cards. So they're gonna start a new game with 4 cards and 3 cards. Play that game to completion. And player 2 won that game. So player 2 gets the 4 and the 3. So he should now be 10, 1, 7, 6, 4, 3. 10, 1, 7, 6. Oh, 3, 4. Yeah, of course, because it's his card first. Yeah. So. Okay. Do decks have an easy way to grab a slice? They don't seem to. Okay, I'm not gonna read the spoiler. I mean, I'm thinking we just do this the easy way, but I'm a bit afraid that copying these decks isn't the fastest thing in the world. So what is it that we actually have here? What's kind of... I mean, a deck seemed like a good data structure, but I'm not entirely sure if it is. We could do a sequence, but then we would have to implement that ourselves. It's a bit annoying that this deck doesn't have like a slice copy. Because now we're gonna have to do something like this, and we're gonna have to sort of slice it ourselves. So that's a bit annoying. Right. Wait, what did that say? None of the procs that get an individual value from the deck can be used on an empty deck if compiled with bound checks. Right. Yeah. That's fine. Let's just do it with decks real quick, and then we'll... If it doesn't work or if it's too slow, then we can change it. So play a game. I guess the first card doesn't matter because they play a completely new game. So we just need to take in player 1 and player 2, which is both going to be a deck of ints, and it's going to return... let's just return a boolean. So true means player 1, 1, otherwise it's 2, or otherwise it's false. So this is the normal case, right? This is the what we've done so far, which is all of this stuff. What we need to implement is this subgame stuff. So if player 1 dot peak first is greater or equal to player 1 dot length, and player 2 dot peak first is greater or equal to player 2 dot length, and we're gonna just do that and return true, false. So I just moved the winning logic into here. So if player 1 that prefers, this means that we should recurse. That means we should play a game with now our 2 new sets. And this is going to be ugly. Because we don't have the copy thing. I mean, we could pass it in with a copy and indexes and stuff. Yeah, I'm getting much of the same that Zoom is saying, that decks are annoying. They really are for this. You know what? Let's just implement the slice real quick. So slices take we're gonna take a deck, which is a deck of int. I'm not gonna make this generic. And a range, or R for range. Into int, I guess. Do a deck of int. For I in R, result dot add last deck I. It's something like that. And now we can do this and say play game for play game for player 1 from 1 all the way to player 1 dot pop first. Why should I make it generic? I'm only using it for ints. It's not even exported. Player 2 and this yeah, I can just store this to result. So if that happens, if that doesn't happen, then it should do this thing. I'm gonna have to move that while loop out. This makes result to true. This sets result to false. We're not gonna do that. We're gonna add logic outside of here. If result, then we're doing this. Otherwise, we are doing this. Oh, quite a lot of red. And for here, we need our logic here. Now we don't have the stopping thing in yet. I'm gonna add that in a minute. Range. Oh, it only has one of these type parameters. Expected range. What? I implemented the slice operator wrong, apparently. It's not something I do a lot, implementing custom slice operators. Come on. Is there a single example of this anywhere? I guess then basics was probably the wrong place to go looking. Oh. It takes a slice. Right, it doesn't take a range, it takes a slice, probably. Yeah. Oh, that should of course be normal, stuff like that. Wait, what? Why is that an error type? Oh. Because these aren't changeable, but we want those to be a copy. So we need to do this. There we go. So the test game, so we don't know about this one, but our test data game, we know. So this one is terminated. Oh wait, maybe one of the sub games. One of the sub games won. Okay, I don't think so. Maybe. Not that one. The one from up here. So we don't have the sub, like we don't have the infinite recursion stopping thing in place. Play this on player 1 and player 2. And echo out the winner and just echo out. Well, those shouldn't have changed. Ah, crap. I need to score this. Yeah, don't do that. Oh, and run this. Out of bounds. Line 43. Turn that back. How is that out of bounds? If it's equal to the length, I guess it will be out of bounds. If we peak the first, yeah, so it has to be larger. Oh no, wait, it has to be smaller. So in this case, it would, where's the first sub game? It's down here. Game one, sub game. So in this case, it checks 4, and 4 needs to be smaller than 5. Yeah, so it's smaller than, just strictly smaller than not. There. What? Line 43. So it complains that check that the first number is smaller than the length. What? Echo out the players here. And echo out just the game. Just we see, just that we can see if it recurses. Is this one 49852 310 176. Yeah, so it's the first recursion here. It says 4. We tell it. Oh, wait. It should be 0. Because this pop first is run before we actually do the slicing. Which also means that we should grab one less number. There we go. False. Which was player 2 winning. And yeah, player 2 won. And he should have 7, 5, 6, 2, 10, 8, 9, 1. 7, 5, 6, 2, 10, 7, 5, 6, 2, oops. 7, 5, 6, 2, yeah. Well, shit. Oh, right. Yeah, this is way too short. So it starts the sub game. And the sub game. You're calling my streams ASMR sub? Right, so this starts with this, and this starts with that, which is correct. ASMR, yeah. I don't think I've actually listened to ASMR. Yeah, here, this is the sub game, which is 910. Yeah, 85217, blah, blah. And then the 8 and the 1, so that is, yeah, 8 and the 1 goes to this player, so now he has 5, 8 there. And this is 7 and 10, 7 and 5, which means that he gets those. And they pop 2 and 10, and he gets 10 and 2. And then 8 and 9, he wins 9 and 8, 7 and 1. Yeah, 8 and 9, 7 and 1. The winner of game 2 is player 2. So now we're back to this game, which now means that this should read 9852. What? And that should read, yeah, because it was the 3 and 4 that triggered the, oh, wait. Yeah, so I pop those off here, which is not what we want. We want to do this with the peak. The peak, and then we want to just discard these two. Well, I should don't discard them because we're gonna be popping them off for the winner. So yeah, like this. That should then be 7, 5, 6. 756-241, 756-241, 10-8-9-3, 10-8-9-3. Yeah. Okay, so that's correct. Now, all we need is the infinite rule. Yeah, apparently people like the audio. I like it a lot myself. I've been listening to a couple of the recordings, and it sounds way better. Someone said it was a little not so loud the other day, so I turned up the volume a bit. Hopefully that fixed it. Anyways, I had set it a bit low on purpose to make sure that I didn't clip. Or, I mean, I shouldn't clip anyways, but yeah, so before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. Previous rounds from other games are not considered. This prevents infinite games. So it should keep basically all of the stacks, or all of the not the stacks, but the decks, or we could hash the decks. I'm gonna input the this. No, not that one. The one that this one. Yeah, so this should now run forever. Which is what we expected. So now, and this is just per game. Right? Before either player deals a card, if there was a round in this game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. Yeah. In this game, yeah. Basically, we need a simple hash. So we need a scene games, which is just a set. I'm gonna just write a very simple hash here. Oops. That gives us a UN16 and instead of something else. So for value in deck, result equals result times 32 plus value. Dot UN16. Should be a simple enough hash that should work. And it should be, well, I guess it's mod the size of a UN16. Should be fine. Right. So before we pick a card, so in each round, before we do this, so this is now an elif, and the result of this is true, which means player 1 won. wins the game. And this state doesn't carry, so we should just return true here. There. If player one dot hash. Oh, it's both of them, right? So we're just gonna do this. If the hash of our two decks is in our scene games, then we return true. In both the other cases, then state hash is just this. Player one, player two. State hash. Scene games include our state hash. There. That should solve that quickly. Yep. It doesn't actually tell me who. Yeah, so player one should have win that one because it ends in a infinite loop. Okay. So now we have all of the rules that we needed. We can try with just double check that our implementation of that didn't mess up this. Here. Just make sure that this is still fine. Just output the what? Right. So that's not great. Right. Wait, what? Is that hashing algorithm just so bad that it returned the same thing for two different inputs? Yes, it is. Oh, right. Binaural. What would the benefit of being binaural? So that when I move around, you would hear me around your head? So I can whisper in either one of your ears? Okay, let's Let's grab Nim's actual hashing thing. But that gives me an actual hash, which isn't quite what I wanted. Are there? I mean, there has to be, right? Some binaural ASMR artists. Is that, do they call themselves artists? I guess they do. Right. There we go. Yeah, so it should be 75624110893. Seems familiar enough. 75624110893. Yep. And I mean, this one should also. This one should also still work. There. Good. True. Which means that player 1, 1. Now, the matter of the scores. I pass in copies of this. Like player 1 and player 2 outside of here wouldn't be changed. I guess we could change that. Yeah, let's change that. So player 1, player 2 are now variable decks. We don't need that anymore. But we also need to make sure that we make copies in here. Player 1 sub. Oops. Go to end of line. Player 1 sub. Player 2 sub. And that should be this. Player 2 sub. There. So that should make these copies. And that should work fine. So now I should have player 1 and player 2 be modified outside of here. They don't seem to be, but that is probably because it halted because it went back to the initial condition and it stopped on that, which is fine. Let's try it with this one. It should actually give us a change. Yep, that looks good. So now we can run. Well, let's run it on that, and then grab our scoring thing, back. Here, I mean, we can move this. Since this returns true, false, we can grab this, pop it in there, and it returns true when player 1 wins. So that should work. And that should give us the score. 291, which I believe was the correct number. 291, yes. That means we can now pop in our actual data. And this should now hopefully work. Gave me an answer. Oh, it was not right. It was too low. Okay. It is too low. Well, that was unfortunate. I have deleted a line in here by accident. I hope. So I mean, it passes the test set, and it gives me the right score for the test set. And it passes this infinite recursion thingamajig. So I'm not quite sure what the problem is. Before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. Yeah, the game instantly ends. Previous rounds from other games are not considered. Yeah. Programming related ASMR. I mean, apparently that's what this is. So, I mean, feel free to send me money. I mean, it might be that our hash algorithm breaks down. Because the set of values is too low. I'm guessing we can't make a set out of hashes. No. Yeah, set is too large. Let's try this with just a hash set instead. I mean, we're making a hash set filled with hashes. We did get a different result, and it complained that this was too low. So I guess this is the right one then. No, it's still too low. Well, the data changed at least. Echo me out player 1 and player 2. Just want to make sure that they, yeah, so one of them has all the values. It's not something silly where one of them like didn't get popped or something. I mean, might be an issue with this, I guess. Let's try something here. Oops. Player 1 hash, player 1 hash, player 2 hash, player 2 hash, and then result as player 1 hash, hash combine with player 2 hash. Oh, and that. Yet another number. And it's bigger. And it still complained that it was too small. Okay, it's obviously... Oh, hello again, angered gecko. Have you had a look at Nim since yesterday? So something is wrong with this hashing stuff. You haven't had a chance to look at it. I mean, that makes sense since you were here last, like, 12 or 24 hours ago. I haven't had time to look at any new programming languages either. And I mean, now it's Christmas and everything. Okay, so this hashing stuff obviously isn't working. Just in case this makes a difference. Yeah, thought so. And it said that the crab was supposed to lose. And the crab is player 2. So I am winning. I'm just apparently not winning in the right way. Oh, now it's too high. It was too low before. Interesting. So we calculate the state hash up here. Yeah. That makes sense. I mean, I feel the logic here makes sense. But this apparently does not. Just out of curiosity, let's run with let's run with the test data here and see that we still get the same result. just in case I just messed it up in some other way. This should be like 291 or something. Yeah. But this one doesn't have those infinite run conditions. But we at least know that it doesn't trigger it too often. Yeah, it works on the example case. And it stops on this like infinite recursion case thing. It stops on that in what I believe is the correct position. It doesn't actually specify, but so it sort of stops in the right position there. And player 1 is the winner in this case, so that should be 19 plus 43 times 2. 105, yeah. So that's correct. No, my scene hash set is not a global. It's in here. And it was supposed to be per game, so that should be right. Just these don't have hashes, do they? No. If I were to guess, it's because of this. I'm gonna do oops, I didn't mean to remove that. I'm gonna do that. And then I'm just gonna double it in between. Yeah, still gives me the same thing. Yeah, I mean, it is possible that we get hash collisions. I did tweak the hashing algorithm, and I did get some different results, which obviously isn't good. I don't think that should be the same thing, right? But yeah, it is possible that we are getting hash collisions. Okay, so let's do this the dumb way then, like the just scene games is just a sequence of tuples of player 1, player 2, and these are dex events. Don't calculate that. Check if player 1, player 2 is in this sequence. Now we can't add them down there. I need to let this I need to build this tuple before I start doing stuff with these. mean, this should be way slower, but okay. This didn't seem to finish at all. A few hours? Is it that? Is it that slow? I mean, now I don't know if it's in 3 million elements. That doesn't sound right. Wait, one game can't possibly go to 3 million elements. Well, I guess it could, theoretically. Yeah, it's not global. I think this has just run into an infinite recursion. And I think it might be because the state updates. Just make a copy of these. This is super ugly. Okay, since this runs so slow, just do a release build at least. Yeah, I mean, it's easy. I could also actually, let's just yank this out in a copy and then revert back to using hashes. And then that should be our worst case. Yeah, mine ends up at 3,000 elements. Yeah, it would be. I just want to check like if it's a hash collision or if we're doing something else wrong. Because that's what annoys me. Oops. No. I mean, it'll be slow, but crap. Let's just build that. I'm gonna run it in. Oh, okay. Just don't do that then. I'm just gonna run it in the background. tuples not hashable? Well, tuples are hashable if their elements are hashable. Oh, that's a good. Yeah, I mean, I guess I could do this and just result. Well, result doesn't really make sense here. Do this and this and that. So now I have one that, oops. Now I have one that hashes only one thing. There should be a hash set of a tuple of pair 1, pair 2 of dex of ints. There we go. If state in and include. Oh, this is finished with the same result. No matter what I do, I get the same result. I mean, this one checks all of them. And I still get the wrong result. I'm going to download this again, just to be absolutely sure. Yep, no, that's the same. Could someone else run this on their working solution? I mean, you don't have to like give me your solution or anything, like the number. Just tell me if you get another number than I do. Because I'm kind of out of ideas here. It works on my test. Or it works on the test set. Or if someone could, you get a different number. Okay. Could you send me your input? Oh, you know what? Motherfucker. Has that always been missing? But this is larger than the number I had. And it complained that my number was too large. Oh, crap. Wait, has it really been missing? It has. Damn it. That would obviously give me the wrong result. And since the test input doesn't have any, it is basically just a shorthand way of doing this. So ranges in nim are inclusive by default. But I want it exclusive. because if this number is 5, I want to go from 1 to 4 inclusive. So 1, 2, 3, and 4, which is 4 numbers. But yeah, that still gave me a larger number. And this is the right way around, and this is right. And that should be right. And the logic for adding these should be fine. Oh yeah, crap, they're indexes. Wait. Would that be right? Now I have a slow version. This seems to have just launched into an infinite recursion. Or it's just slow. Okay, you know what? I'm gonna revert to one of my versions that was faster, because waiting for these was kind of tedious. Yeah, I don't want that there. Wait. Yeah, this should be good. This should be fast, right? Yeah. And if I add this, I get a bigger number. If I remove them both, I get a smaller number. There we go. Oh my god. That was that was painful. All the back and forth with different hashes, and I mean, I don't think this is necessary, or this, or this, or this, or this, or this. This should probably give me the same result still. No. Okay. So that was actually necessary. Was it necessary to couple it out? You know what? I don't care. That's my, oh. That's not my correct solution. Wait, what? This should be the correct solution, right? What happened now? I managed to mess up my working solution. Oh, through to right. Okay, this is the correct one. Good, okay. Yeah, it was a typo all along. Yeah, because I originally had it like this with a pop over here. But that was wrong for other reasons. But when I refactored that, I apparently forgot one of those. I mean, this code is just a mess. And this hashing algorithm is not pretty, to put it that way. I wonder if we do the tuple thing. Wait, does a hash set stores the values, right? So that would still require a large amount of memory, which I don't want to use. I'm still a bit surprised that this is needed, to be honest. Oh, it wasn't. Wait, what was I removing earlier? If that works. Yeah. Yeah, because you can iterate over the values, which is like you can get the values back out. I mean, there is a neater way of doing this, but yeah. And someone asked how fast this was, or people over in the NIM IRC channel have been comparing their times. I don't think this is very fast. Up in the triple digit milliseconds. Not great. What was it? Narimiran got it down to 1.5 millisecond. 20 before optimizations. Wow. Yeah, I guess my biggest point of optimization is probably in here. I mean, this might be this is probably an issue as well. Or I say issue, it's probably a not very fast thing. But you kind of have to do this. I don't know how fast iteration over these decks are. I think it's pretty decent. But yeah, this copying out of the deck and making a new deck, that's gotta be slow. Oh, I'm reading chat from just the main NIM IRC channel. IRC / Discord / Gitter. They're all merged together into one big channel. Yeah. But yeah, this copying here is probably the slowest bit, I guess. Yeah, I thought about using the score, as it is kind of a hash. And then I implemented my silly hash to begin with, and that didn't work at all. Which is why I implemented another one. and I thought, well, let's then actually use the hash module if I was having hash collisions. But how? Yeah, so you just have the two, you score both of them, and then you because there are two non-empty stacks, right? Or decks. So if you hash, like if you score, you need to score both of them and then combine those somehow. Anyways, that's quit out of that. That was day 22. Easy enough once I stopped making silly mistakes with my typing. At day 22. There we go. Can I have a look at the map now? So we're still just rafting along down here. It looks like we might have one final obstacle before we reach our destination. Still, as you can see, I still haven't done part 2 of day 20. I'm still in the same place. Like I know where each of the tiles go, but not their rotation and flipping. And I just can't be arsed to actually implement it. So I might go back and do this at some point just to get that. Oh wait, yeah, day 20 part 2. Yeah, I mean that was a surprisingly tricky one. I didn't like that one at all. But yeah, that is today's Advent of Code. Let me just check the leaderboard. The NIM leaderboard. I mean, I shouldn't be that high up because I don't finish them like really quickly. Yeah. Because you get 0 points if you get 0 points if you don't do one, right? Or if you do it a day late, you don't get any points, right? So you have to do them like on the day. There are some people here who aren't doing them in them. Yeah, so after I started streaming, I dropped a bit because I do them after work now instead of like during lunch. But yeah, anyways, that was pretty much it for today. Quite a long stream today, even though it wasn't all that hard, annoyingly enough. And yeah, I hope you continue having a good Advent and a good or a Merry Christmas when that rolls around in a couple of days. I'm not sure if I'll be able to stream tomorrow. I think I might. And the day after tomorrow, probably not. So on Christmas Day, probably not. So if I don't see you, or if I don't do any more of these, then I guess Happy New Year's as well. Yeah.